Welcome back, guys, to question number 2 of May-June 2025 variant 3 theory paper for chemistry, and on to some nice easier questions. At least the first question, although only 1 mark each, the problem is they are quite tricky and take a lot of thinking, but at least we're on to some easy stuff. So state which of these particles are found in the nucleus of the atom. So we've got protons and neutrons and electrons not in the nucleus, so we have to write both to get the mark here: protons and neutrons. Okay, then we're on to atoms of the same element are known as isotopes, have different numbers of neutrons. Okay, we can see that here they have the same proton number. The bottom number, the smaller number, is the proton or the charge number, and then on top is the nucleon number. And they're leading you in this question because they've just asked you what is a nucleon, essentially. Sorry, the nucleon number is the number of protons and neutrons added together. So this is just going to be a math problem now. So we haven't got any charge. Okay, so it's neutral, so it's an atom, which means the number of protons and the number of electrons is the same because electrons are negative, protons are positive. If it's neutral, they have to balance each other out. Okay, so then neutrons, how are we going to work that out? We're going to do the nucleon number minus the proton number to get us the number of neutrons. So 34 minus 16, which is 18. Okay, on to the next one. We can see that we do have a charge and we have 2 minus. Okay, that means we must have 2 extra electrons because electrons are negative. So that means whatever we have before, now we're going to add 2. So 16, 17, 18. So now this is 18, making the charge of this 2 minus. 2 extra negative particles in the ion. So then the number of protons has to be 16. Because to be sulfur, what defines each element is the proton number. You cannot have sulfur as an element and the proton number being not 16. And on to the number of neutrons, we're just going to do the exact same process as we did before. We're going to do 32 this time, the nucleon number minus the number of protons, which equals to 16. And it makes sense because we had 34 and now we have 32 nucleons, which is 2 less neutrons. Next question. We've got to work out the relative atomic mass. The relative atomic masses that are on your periodic table are worked out exactly the same way that we're going to work it out. So, for example, chlorine has a relative atomic mass of 35.5. How can an atom have half of a nucleon, for example? How does that work? Well, actually, this is an average. So that's what we are calculating today. We're calculating the average depending on the percentage abundance of the isotope. So what we're going to do is we're going to do 95. So the first percentage abundance times by its relative mass plus the relative abundance of the second one times by its relative mass. Then we're going to divide by the total relative abundance, which is 95 plus 5. So that's going to equal 95 times 32 plus 5 times 34. And we're going to work this whole thing into the calculator, and that will give us 32.1. If you get the wrong answer, practice using this button on your calculator, putting everything at the top. You can write it exactly like this, you won't need any brackets, and dividing by 100. So on to the next one. The relative atomic masses of all elements are compared to 1 atom of an isotope, and this is a good one again for a flashcard, and that is carbon 12. All of them are related to carbon 12. So we're on to 2C. Ions are atoms or groups of atoms that have gained or lost 1 or more electrons, kind of like that sulfur above with that 2 minus. Sulfur is an ion because it gained 2 extra electrons and it has that charge of a 2 minus. Okay, so then they've told us an oxygen atom. So we're talking about an atom, it's not charged. So an oxygen atom has the electronic configuration of 2, 6, that just means it has 2 electrons in its first shell and 6 electrons in its second shell. We've drawn this oxygen atom to the right. Obviously, there's protons and neutrons in the centre, but right now we're not interested in that. Give the formula of one atom and one positive ion that has the same electronic configuration as O2-. Right, 2-. Has it gained electrons? Has it lost electrons? Here it's gained negative electrons. So they've probably gained this from a metal or something like that. So I'm just going to draw 2 extra electrons on our little diagram to the right. So now we're looking for a full second shell, which means we're going to be in group 8 or group 0. So let's look at our periodic table for an element, well, an atom that has the same configuration as what we've drawn. Up here we've got 2 in the first shell and 8 in the second shell, which means we're going to be in group 8, okay, and we're going to be in period 2 because we've got 1 shell and we've got a second shell. So first shell and second shell, and we can see that this is neon. We can even double check. Let's look at neon has 10 protons, which we can see here, which means if we have 10 protons, we must have 10 electrons for it to be neutral. Let's draw 10 electrons in these shells. So in the first shell, we can only fit 2. In the second shell, we must have 8 more, which matches what we've got drawn for O2- above. Okay, on to the next one. A positive ion compared to our diagram here. Okay, so now we've got to give the formula of one positive ion that has the same configuration as what we've drawn in this box here. We've got to have the same electronic configuration as neon. Same electronic configuration as neon or O2-, but now it's got to be positive. If it's positive, that means it must have lost an electron but have the same configuration, which means we're going to go to the next line and we've got to think things that lose electrons are metals. So we're not going to choose a non-metal from this side, so we can't choose any of these. We've got to choose aluminium, magnesium or sodium, because all of these 3 will lose electrons easily. So let's do an easy one. Let's do sodium, which has 11 electrons as an atom, which would be 2 in the first shell, 8 in the second shell, and of course in the shell after that there would be 1, because of course it's in group 1. But we want it to be positive, so it's going to lose that electron, and then it will be the exact same as what we've drawn up to the right. Okay, so what we're going to write is sodium 1+. We could also write magnesium 2+, or aluminium 3+.